Good morning, everyone. Am I audible? Good morning, everyone. Am I audible? Good morning, everyone. Please join fast. Am I audible? Akshit, unmute yourself. Akshit may unmute himself. Am I audible? Akshit,
Yes, sir.
am I audible?
Yes, sir.
Okay. Very less students have joined today. Today we can start limit and derivative. Limit and derivative. what is the mean of limits or how to find the limits. Mainly we shall discuss here. And then using the concept of limits, how to differentiate some function, the basic definition of the differentiation, and some formulas used in differentiation and their application. The basic concepts only we shall study, because the remaining parts in details we have to study in class 12th also. So in class 11th only the basic concepts of the differentiation or derivative is there and limits are there. So limit means, suppose if I define any function fx equal to x plus 2 and we want to find its limit x tending to 2 fx. So limit x tending to 2, please do not confuse with limit x tending to 2 and x equal to 2. Both are slightly different. Tending to 2 means value is approaching towards 2. Value is approaching towards 2 means it can approach towards 2 from two sides, either from right or may from left. Approaching from right means value is slightly more than 2. Means it is 2.1, 2.01, 2.001. Means from right side. Initially it was more than 2 and by it is decreasing itself to approach up to 2. Similarly, approaching from left means the value was 1.9, 1.99, 1.999. So that means call that it is approaching from left side. Means it was slightly less than the 2 and trying to be equal to 2, or approaching from left up to 2. So if you put the value more than 2, slightly more than 2, then this value will be equal to, if you take 2 plus h plus 2, where limit h tending to 0, we shall have limit h tending to 0, 4 plus h. Since h is tending to 0, it can be neglected. So this value becomes 4. So if we are taking the value slightly more than 2, then it is called right hand limit. Means there are two limits. Right hand limit. Right hand limit. It is written as RHL. Similarly, if it is approaching from left, if you take the value slightly less than 2, limit x tending to 2 minus. Here we write 2 plus. For right hand limit, we write 2 plus, means value is slightly more than 2. Approaching to 2, nearer to the 2, but it is slightly more. Then we write 2 plus, or we take here 2 plus h, where h tending to 0, and we call it from it as RHL. The value which comes for the function, that value is termed as right hand limit, RHL. Similarly, we take the value slightly less than 2, fx, or you may write limit h tending to 0, fx minus h. This will be nothing but 2 minus h plus 2, that is 4 minus h, where h is limit h is tending to 0. So this value also comes 4 if we ignore 2. Then limit of the function is said to exist if and only if this left hand limit is equal to right hand limit. Keep in mind, limit exists if and only if left hand limit is equal to right hand limit. If the value of left hand limit and right hand limit are not equal, then we say that limit does not exist. If I write limit x tending to 2fx, where fx equal to x plus 2 exists, it means its left hand limit and right hand limit should be equal. Means if we take the value of x slightly more than 2 or slightly less than 2, in both the cases the value should be nearly equal. I hope the concept of the limit is clear to you. Then some applications of this limit. There are so many theorems related to this. Limit x tending to c fx, limit x tending to c alpha constant, that remains constant itself. If I define limit x tending to c, and here we write alpha, where alpha is a constant, this value comes equal to alpha itself. Constant function, if fx is a constant function, then its limit does not change by changing the value of x. If we write limit x tending to c x to the power n, then this value becomes c to the power n itself. Directly also it can be written c to the power n. Similarly, limit x tending to c fx equal to fc. If instead of this x to the power n, we write limit x tending to c fx, this value will be equal to fc. The fourth case is, if there is any modulus function, modulus of the function is defined, then limit x tending to c modulus of x equal to mod of c. Limit x tending to c mod of x, this becomes mod of c itself. Then comes the algebra of limits. If alpha is a constant and fx is a function, then algebra of limits. Algebra of limits. Limit x tending to c alpha fx, where alpha is a constant, then this alpha will be coming first. Alpha will be multiplied here into fc. If limit x tending to c fx equal to L and limit x tending to c gx equal to m, if limit x tending to c fx equal to L and limit x tending to c gx equal to m, then limit x tending to c fx plus minus gx. If you are taking here plus, then it will be here also, right side also there will be plus. If we take here minus, right side also will be minus. This equal to limit x tending to c fx plus limit x tending to c gx separately. That will be L plus m plus minus m. Similarly, if we write their product or differentiation division, then also it holds true. That is, we can write limit x tending to c fx into gx, that can be written as limit x tending to c fx into limit x tending to c gx. Similarly, we can write limit x tending to c fx upon gx. This will be nothing but limit x tending to c fx numerator upon limit x tending to c gx. So these are some of the important. If similarly limit x tending to c 1 by fx is there, it will be limit x tending to c 1 by fx, provided denominator is not here. Condition is this is not equal to 0. So this comes from the basic definition of the rational expression itself. If in case of the any rational expression denominator is 0, then that expression is not defined. Then there are some basic theorems regarding. Before that, we shall start the sandwich theorems. If we take three functions f, g, and h such that if we take three functions fx is less than or equal to gx is less than or equal to hx, then if you take limit x tending to c fx, it will be less than or equal to limit x tending to c gx, and it should be equal to less than or equal to limit x tending to c hx. This theorem is called sandwich theorem. If limit x tending to c fx equal to 0 and gx is any function, then in that case limit x tending to c fx into gx will be 0. If limit x tending to c fx equal to 0, then this implies limit x tending to c fx into gx, where gx is any bounded function. So this term will be 0 now. We can write this limit x tending to c fx into limit x tending to c gx. So as we know, limit x tending to c fx is 0. So 0 when multiplied by any expression, this result gives 0. So limit x tending to c minus or limit x tending to c plus or limit x tending to c can be written as, in place of limit x tending to c fx, this statement we shall widely use. Limit x tending to c fx can be written as limit h tending to 0 fx plus h, or this x also we can replace by c plus h, c plus h or c minus h, whatever you want to write, you may write. One more theorems. Limit x tending to a x to the power n minus a to the power n upon x minus a. This value becomes n into a to the power n minus 1. This will be widely used. Many expressions will come like this, and directly you may write. Suppose there is given x to the power 6 minus a to the power 6. In place of a, there is given 3 to the power 6. So n will be coming first, 6 will be coming first, and 3 to the power n minus 1. That is 3 to the power 6 minus 1, 3 to the power 5. Likewise, this theorem will be most widely used. So I hope up to here it is clear to you. Then there are some more results on trigonometrical function. Limit x tending to 0. Limit x tending to 0. If I take sine x, there is nothing to explain much. Whether value is slightly more than 0 or less than 0, if x is tending to 0, then value of sine 0 is 0 itself. So this will give the result 0. Similarly, limit x tending to 0, if we take the function cos x, this value comes 1, and limit x tending to 0, tan x will be 0. These are very important results in trigonometry. Results you can understand better. Limit x tending to 0 sin x, its value is always 0. Limit x tending to 0 cos x, so cos 0 is 1, we know. So if a limit we are finding where x is approaching towards 0, either from left or from right, then value becomes 1, and limit x tending to 0 tan x becomes 0 itself. So these three are important result. Then limit x tending to c, sin x becomes sin c. Limit x tending to c, cos x becomes cos c, or tan x becomes tan c. If limit instead of tending to 0, if we write limit x tending to c, sin x becomes sin c. Limit x tending to c, cos x becomes cos c. For example, if I write limit x tending to pi by 4 sin x, then this value will be sin pi by 4 itself. The value of sin by pi by 4 is 1 by under root 2. So this will be the way to apply it. If similarly we write limit x tending to c, tan x becomes tan c. Or any trigonometrical ratio, in place of x you write c. Whatever the value of c there, find the corresponding value of the angles. Then if limit x is tending to 0, then again there are three more important results. Limit x tending to 0, sin x by x equals to 1 equal to limit x tending to 0, tan x by x. And this equal to limit x tending to 0, 1 minus cos x upon x. Limit x tending to 0, sin x by x becomes 1, because limit x tending to 0, sin x becomes x. Similarly, limit x tending to 0, cos x becomes 1. Limit x tending to 0, sin x by x 1, tan x by x 1, and limit x tending to 0, 1 minus cos x by x becomes 1. Sorry, this will be 0. 1 minus cos x by x, this value will be 0 if limit x tending to x is 0. So these are the important results of limits in trigonometry. Then now we shall start some concepts of the derivatives. What is the derivative? That concept we shall see. But before starting that, some basic concepts of the exponential and logarithmic functions also will be coming there. How to find the limits of the exponential function and limit of logarithmic functions. Some basic rules. Limit of exponential function and logarithmic function. Limit x tending to 0, e to the power x, that becomes 1. Because if we take the power 0, e to the power 0 or a to the power 0, any base power 0 becomes 1. So if limit x tending to 0 we are finding for e to the power x, it becomes 1. And similarly, limit x tending to c, if we write e to the power x, then it becomes e to the power c itself. Limit x tending to 0, a to the power x also becomes 1. In place of base e, if you write base a, limit x tending to 0, a to the power x becomes 1, and limit x tending to c, a to the power x becomes a to the power c. You may notice the difference. Limit x tending to 0 here, and here it is approaching towards c. C may be any number, x tending to 1, x tending to 2. So the value will get changed. Limit x tending to c, log x if you take, it becomes log c. This is 2, 3rd, 4th, 5th. Limit x tending to c, log x becomes log c. Keep in mind, Yes, C should be always positive numbers. C cannot be 0. That's why I did not write a limit extending to 0 log x, because log of 0 and negative number is not defined. Log of always of positive number is only defined. So here the value of C must be positive. Then 1 plus x to the power 1 by x, limit x tending to 0, limit x tending to 0, 1 plus x to the power 1 by x. This value becomes E, where this E is called a constant. This constant is Napier's constant, and the value of this constant is 2.718. That you have to keep in mind. So limit x tending to 0, 1 plus x to the power 1 by x becomes equal to E, where what is E? E is Napier's constant. The value of E is merely 2.718. Its name is Napier's constant. Keep in mind. Napier's constant. Then limit x tending to 0 log 1 plus x by x becomes 1. Some more results. Limit x tending to 0 log 1 plus x upon x. This value becomes 1. And limit similarly x tending to 0 e to the power x minus 1. Limit x tending to 0 e to the power x minus 1 upon x. This value also becomes 1. Limit x tending to 0 a to the power x. Limit x tending to 0 a to the power x minus 1 upon x becomes log x or log a. So these are the important results related with the limits of the function. I think time is up. Today I was to start a derivative also. So you may try all the exercises based on limits. Derivative we shall start tomorrow. And already conic section we have completed. Some topics are left in conic section also. So one period I'll give for conic section and one period for the derivative of the function. Then after this, only 2 topics are left: mathematical reasoning and statistics. Probability already videos I have sent, and if doubt comes, you may discuss on that. And if time I get, one period I'll discuss on probability also. So today we can wind up. Again, tomorrow I'll try to manage one period and we shall finish derivatives. And if you have doubts in limits, you may discuss your doubts also tomorrow. Okay, thank you. एक टॉपिक डेरिवेटिव हमको डिस्कस करना है। एप्लीकेशन डेरिवेटिव नहीं एप्लीकेशन नहीं है, केवल डिफरेंशिएशन फिजिक्स में पढ़ाए हैं वही चीज